Hi, welcome to Computer Science Explained. In this video, we will talk about logical operators. In the realm of programming, conditions and logical operators are fundamental concepts that drive the decision-making capabilities of software. They allow programs to perform different actions based on certain criteria, making them dynamic and responsive. Conditions are expressions that evaluate to either true or false. They form the basis of decision-making in programming. By using conditions, a program can execute certain code only when specific criteria are met. Conditions are used in branches, for example if and switch, and also in loops, for example for and while. Logical operators are used to combine multiple conditions or to invert the truth value of a condition. The three primary logical operators are NOT, AND, OR. NOT operator is a unary operator. In other words, it needs one input argument. Let's build a truth table of the NOT operator. If x is false, not x is true. If x is true, not x is false. True can be substituted with 1 and false can be substituted with 0. The set theory complement operator is the analog of the logical NOT operator. The complement of x is all except x. Of course, true is all except false, and false is all except true. Let's see what will happen if we try to apply the NOT operator twice. We take NOT x and apply one more NOT. It's all except NOT x. As you can see, it's just x. So applying NOT operator twice does not affect the result. So we can cancel not just one, but any number of NOT operator pairs. AND operator is a binary operator. In other words, it needs two input arguments. False and false is false. False and true is false. True and false is false. True and true is true. So, as you can see, only when both input arguments are true, the result is true. AND operator is the multiplicative operator, because it functions like the multiplication operator. 0 times 0 equals 0. 0 times 1 equals 0. 1 times 0 equals 0. 1 times 1 equals 1. Also, AND operator can be emulated by the minimum function. Minimum of 0 and 0 equals 0. Minimum of 0 and 1 equals 0. Minimum of 1 and 0 equals 0. Minimum of 1 and 1 equals 1. The set theory intersection operator is the analog of the logical AND operator. Both x and y must be true to obtain true. OR operator is a binary operator. In other words, it needs two input arguments. False or false is false. False or true is true. True or false is true. True or true is true. So, as we can see, only one true input argument is sufficient for the result to be true. OR operator is the additive operator because it functions like the addition operator. 0 plus 0 equals 0. 0 plus 1 equals 1. 1 plus 0 equals 1. 1 plus 1 equals 2. But of course 2 is not 0 or false. 2 is true. So we can substitute 2 with 1. Also, OR operator can be emulated by the maximum function. Maximum of 0 and 0 equals 0. Maximum of 0 and 1 equals 1. Maximum of 1 and 0 equals 1. Maximum of 1 and 1 equals 1. The set theory union operator is the analog of the logical OR operator. Just true x or true y is sufficient to obtain true. Let's talk about the priority of logical operators. In mathematical expressions with plus, minus, multiply and divide, addition and subtraction must be calculated after multiplication and division. Logical operators must be calculated in the next order: not, and, or. Not is a unary operator, so it is quite logical that it is calculated first. And is a multiplicative operator, so it must be calculated before or, which is an additive operator. Of course, parenthesis changes the order of operators. Expressions inside parentheses must be calculated first. This is the simplest condition in the if-else statement without logical operators. 40 is greater than 20. The condition is true, so the first string will be printed. If we initialize variable a with 10, the condition will be false and the second string will be printed. Now let's see examples of using conditions with logical operators. Let's calculate the condition step by step. 20 is greater than 10 is true. 50 is less than 20 is false. Not true is false. False and false is false. So the second string will be printed out. Now let's initialize variable x with 5 and variable y with 15 and recalculate the same condition. 5 is greater than 10 is false. 15 is less than 20 is true. Not false is true. True and true is true. So the first string will be printed out. Another example. 5 is greater than 60 is false. 5 is less than 0 is false. 60 is greater than 40 is true. Not false is true. True or false is true. True and true is true. So the first string will be printed out. Now let's initialize a variable x with 70 and variable y with 20 and recalculate the same condition. 70 is greater than 20 is true. 70 is less than 0 is false. 20 is greater than 40 is false. Not true is false. False or false is false. False and false is false. So the second string will be printed out. Thanks for watching. See you next time.